Using moment area method, find the slope at A, B and C and deflection at C and D. This is the question of simply supported beam carrying uniformly distributed load and point load. If we observe the flexural rigidity, then for part AB it is 2EI and for part BC it is EI. So for different flexural rigidity we will use conjugate beam method. Now first step is to draw the bending moment diagram. Now we know that at the free end, that is at point A and at point C, bending moment is 0. So we have to mark the point A and point C at 0 bending moment. So we will show here the value 0. Now how to calculate the bending moment at point D? So we can take the summation of moment of forces either on the left hand side or on the right hand side. So I will take the summation of moments of forces on the left hand side. So here 0 kilonewton at point A is the force. Now if I move the compass about point D in the direction of the 0 kilonewton, then here is the direction. So for clockwise direction on left hand side, we have to use positive sign. So this is the sign convention, and for anti-clockwise direction we will use the negative sign. But the magnitude is 0. So 0 multiplied by 3, that is equal to 0. So moment at point D we have to mark here as a 0. So I will mark this point at point D and the value is 0. Now we will take the moment at point B. So again we will take the summation of moments in the from the left hand side. So about point B, if I move the compass, then in the direction of 0 kilonewton, then there is clockwise direction. So use positive sign. So 0 multiplied by this distance from A to B is 6. So 0 multiplied by 6. Now we will move to the next force, which is 30 kilonewton. Now about point B, if I move the compass, then here is anti-clockwise direction. So for anti-clockwise direction on the left hand side use negative sign. So we have to take minus 30 multiplied by distance between D to B is 3. So when we calculate this we will get minus 90. So we have to mark the minus 90 point at point B. So here is the extension of B. So I will mark here minus 90. Because of minus sign we have to show the downward direction. Now at point C it is 0. Now we will connect all these points. So from 0 to 0, in between part A to D we have to draw this line. Then from D to B, here is the point load, and because of the point load we have to connect with straight line. So here I will connect this D to B. Now what about B to C? It is uniformly distributed load, so we have to draw the parabolic shape. So from B to C, because of uniformly distributed load, draw this shape. So this is the bending moment diagram. So this first step is getting completed. Now we will move to the step 2. Draw M by EI diagram. So values of M are 0, 0, minus 90, 0. And we have to divide with EI. Now if we observe for this part AB, value is 2EI. So 0 by 2EI at point A, 0. At point D, 0 by 2EI, value is 0. At point B, minus 90 by 2EI. So it is minus 45 by EI. So I will show here minus 45 by EI. Now we will move to the part BC. Now for part BC it is EI. So point B is the part of this 2EI as well as EI. So I will take minus 90 divided by EI. So it is minus 90 by EI. So I will mark here one point, minus 90 by EI. Now we have to connect all these points. So again we will connect 0 to 0. Now from this 0 to minus 45 by EI, and then minus 45 to minus 90. So in this way we have to connect, and then from minus 90 to point C, because at point C it is 0, so 0 by EI is 0. So again we have to show the parabolic shape, because the part BC is having uniformly distributed load. So this is M by EI diagram. So the second step is getting completed. Step 3 is to find the area as well as centroid. If we observe the diagram for the section DB, we will decide this is the area A1, and for the section BC we will decide the area A2. Now we will first find out the area A1 for this section DB. Now it is of the triangle shape. Now we know that area of triangle is equal to half multiplied by base multiplied by height. Now here is the perpendicular line. So we can say that this is the base DB and here is the height. So what is the value of base? So base is equal to 3 meter, and value of height, so from this point up to this point it is minus 45 by EI. So when we calculate we will get the answer minus 67.5 by EI. Now next we will calculate the centroid C. So for this triangle, how to calculate the centroid C? So it is along the line DB. Now if we observe, here is the perpendicular. Now from this perpendicular point, the distance of centroid is equal to h by 3, and the remaining distance is 2h by 3. So this is important point. So this is 2h by 3 and here is h by 3. So h is the total length of this DB and DB is equal to 3 meter. So we can say that this centroid C is equal to this 3 by 3, that is equal to 1 meter from point B, and if we put h is equal to 3, then we will get it is equal to 2 meter from point D. We will calculate area A2 and we will apply the formula. How to calculate area? Area is equal to integration from A to B mx divided by EI into dx. So this mx is the moment of the forces about the section xx, and it is at a distance x from the free end. Now if we observe for the section BC, the end C, that is the free end C, is nearer to this section. So we will take the distance x from the end C and we will take any section xx in between B to C. So it is uniformly distributed load. So what is this magnitude of the load at section xx? So I will show here. The magnitude is equal to 20 multiplied by x, because the load is 20 kilonewton for 1 meter, and for the distance of x, here is the question mark. So we will cross multiply 20x divided by 1. So this load is equal to 20x. And where is the point of application of load? So it is at the center point. So here is the section xx. This is the end C and this whole distance is x. So we will divide this distance x into two parts, x by 2 and x by 2. So at the center there is the point of application of this load. Now how to take the moment about this section xx? So if I move the compass about section xx in the direction of 20x, so here is the direction, clockwise direction. So for this right hand side, this force is on the right hand side. So on right hand side, for the clockwise direction use negative sign. So we can say that mx is equal to minus 20x multiplied by this distance between xx and this force, that is x by 2. So this x multiplied by x square, and 20 by 2 is 10. So minus 10 x square. This is the value of mx. Now how to calculate area A2? Now for area A2 we will apply this mx for this section BC. So what is the flexural rigidity? It is EI only. So here we have to keep as it is. And what is the value of A to B? So these are the values of the x. Now if we observe the value of x at point C is equal to 0. So we will show here value of x is equal to 0, and at point B, because this value of x is moving towards the left hand side, and at B x is equal to 3. So from the diagram we can say that. So for A2 we will write the formula, that is from 0 to 3, integration from 0 to 3, mx that is minus 10x square by EI into dx. So how to solve this? So we have to take the integration. So integration of this x square we have to take. So I will take minus 10 by EI outside the integration. Now integration of x square. So we have one formula, integration of x raised to n is equal to x raised to n plus 1 divided by n plus 1. So x square, n is equal to 2. So x cube by 3. So I will write here x cube by 3, and for this we will give the limits 0 to 3. So instead of x we will put 3. So 3 cube. So we will take here as a, which is equal to 3 cube, that means 3 multiplied by 3 multiplied by 3, that is 27. So 27 into minus 10, minus 270 divided by 3, and next value is 0. So this whole term will become 0 and minus 3 EI. So when we simplify this, minus 90 by EI. So this is the value of A2, minus 90 by EI. Now we will calculate for the centroid. Now for centroid we will use the formula, but instead of mx only we will take mx multiplied by x, and for this whole we have to take the area. Now for the section BC we will take the area A2. So I will write this formula to calculate the centroid for BC. So which is equal to integration from A to B. So again integration of A to B, that means 0 to 3. mx. So mx is minus 10x square. Minus 10x square into x into dx, because here is x, we have to multiply. Now divided by EI. Now for EI value for section BC is EI only. So I will take EI and whole divided by area. So area we have to take as a A2. So this is we have to solve. So minus 10x cube by EI. So minus 10 by EI I will take outside the integration. So we have to first solve this numerator only. So if we solve this numerator only, then minus 10 by EI we will take outside the bracket because it is the constant. Then integration of x cube. So integration of x cube, x raised to 4 by 4. And we will give limits, that is 0 to 3. Now again we will solve this, that is 3 raised to 4 minus here 0. So only 3 raised to 4 and divided by EI, divided by this A2. So we will take the denominator, A2 is minus 90 by EI. Now if we observe this EI is getting cancelled and we have to solve this. We get the calculated value of C is equal to 2.25 meters. So it is the value of x and it is the distance from the point C. So we have to locate this centroid. So if the centroid position is 2.25 meter from this point C, then the remaining distance is 0.75 meter and the area A2 is minus 90 by EI. In the same way, for section DB also we have to locate the centroid, that is we have to show this distance from this point D as well as from this point B and the area also, that is this is the area A1. Now step 4 is find the slope as well as deflection. If we observe AB is the simply supported beam, so we have to show this part AB. Now for this part AB, because of the load at this point D, if we consider here is the bending of this part AB in this way, then the angle made at A is known as theta A and angle made at B is known as theta B. Now this whole distance A to B we will say L, that is the length L. Now I will draw tangent at the slope at this point A. So here is the tangent at theta A. Now in the same way I will show the tangent at this point B, that is the tangent at theta B. Now we will make one construction. If I draw one perpendicular line from this point B, so why we select this point A and point B? Because these are the supports. So here if I draw one perpendicular line from the point B on this tangent at this theta A, then this vertical line will be TBA. And if I draw one perpendicular line from the A on the tangent at B, then this line will be TAB. Now how to calculate this TBA? So it is the moment of M by EI diagram between A and B about B. So if we observe this A to B diagram, so in between A to B we have to take the moment of M by EI diagram. So we will take the moment of this diagram about the point B, then we will get TBA. So how to take this moment of M by EI diagram? So moment of this diagram is equal to area multiplied by centroidal distance. Now I will locate the point. So here is point A, point D, point B, point C. So area multiplied by centroidal distance about this point B, then we will get this value TBA. Now if we observe in between A and B, we have to find out all the areas and all the centroidal distance. So here area A1 and centroidal distance from B, that is equal to 1 meter for this area. So we have to observe this section DB, and for this section AD there is no area, no centroidal distance. So how to take this moment? So again we will apply the rule. So if I move the compass, then here we will get this minus, so here already sign is given. So we will take here minus 67.5 by EI multiplied by 1. So this is TBA. So no need to take here sign convention, because already when we calculate area we get the sign. So this is the TBA. Now if we observe this diagram, then here is the triangle. I will say A, B and P. So in triangle ABP, this TBA is known. This value of L is equal to 3 plus 3, 6 meter. Then we can calculate this theta A. So theta A is equal to TBA divided by L. So we will get minus 11.25 by EI, and this theta A, that is this angle, is in radians. So we will get this negative value. So for this negative value we have to show the direction of the slope is in the anti-clockwise direction. If we observe the diagram, in between theta A and theta B, value of theta A is known. So how to calculate this theta B? For that we will find out theta AB, and theta AB is equal to area of M by EI diagram between A and B. So in between A and B we have to take this addition of the areas. So there is only one area in between A and B, and it is minus 67.5 by EI. So value of theta AB is minus 67.5 by EI. So theta AB is equal to theta A minus theta B. Now when we put the value of this theta A, then we will get the theta B 56.25 by EI radians. Now here is the positive sign. So we can say that this direction for this slope is in the clockwise direction. Now we will calculate deflection at point D. So here is this beam AB and the position of the point D. If we consider this bending of the beam AB is in the downward direction, then we will show the final position. So from this point D up to this point D dash. Now this D to D dash is known as deflection delta D, and we have to calculate this. Now if we observe the slope at A as well as slope at B, it is at an angle theta A and theta B respectively. Now this theta A value is known. Now from this point D dash, if I draw one perpendicular line on this tangent at theta A. So if I draw here, then from distance from this point of intersection up to D dash is known as TDA. So this is the TDA, and this delta D is equal to this TDA minus theta A multiplied by the distance AD. Now distance AD is known from the diagram, it is 3 meter. So first we will calculate this TDA. So how to calculate this? So it is moment of M by EI diagram between A and D about D. So because there are 2 points D and A, so we have to take the moment of M by EI diagram. So we know that how to take this moment, that is area multiplied by centroidal distance from the D. So if we observe, there is no any area and no any centroidal distance, so TDA is equal to 0, and therefore delta D is equal to TDA, that is 0 minus this theta A, it is minus 11.25 by EI multiplied by 3. So we will get the answer 33.75 by EI meter. So this is the positive value. So its unit is meter. So because of positive value, we can say that this deflection is in the upward direction. So this was our assumption. So for the understanding purpose, this bending is in the downward direction, but in actual practice we can say that this D to D dash will be in the upward direction. So the bending is in this way. We will calculate deflection at point C. If we consider this bending of this part BC is in the downward direction, then we will draw one tangent to this bending at point B. So I will show here this tangent line, and this is known as tangent at theta B. So because this slope theta B is known at point B, and we will show here it is theta B. Now if we observe, this bending is in the downward direction. So this is the original position and this is the new position C dash. So this C to C dash is known as deflection delta C, and we have to calculate this. Now from point C dash, if I draw one perpendicular line on this tangent at theta B, then from C dash to this point of intersection is known as TCB, and we have to calculate TCB to calculate this delta C. So what is this TCB? So it is moment of M by EI diagram between C and B about C. So how to calculate moment of M by EI diagram? So we have to take the area in between B and C. area multiplied by centroidal distance from point C. So this area is minus 90 by EI multiplied by centroidal distance from C, it is 2.25 meter. So when we calculate, we will get minus 202.5 by EI. Now from diagram, how to calculate this delta C? So delta C is equal to TCB minus multiplication of theta B and the distance between B and C. So this distance between B and C is equal to 3 meters. So we will put the values. So this multiplication we have to take in the bracket, and then when we solve, then we will get delta C is equal to minus 371.25 by EI meter. So negative sign indicates that this deflection is in the downward direction.